Hello. In this lesson, we're going to continue the topics on quadratic functions. And this time, we're going to talk about a very important technique called completing a square of a quadratic function. We understand the general form of quadratic function, which is this, right? This is a general form. And last time, we have discussed various functions, okay, as special cases of quadratic function. Of course, this is the one. The other one we did was negative x squared, right? We studied the graph of these two functions, right? We studied the graph of these two functions. As a matter of fact, we had a good summary. So I'm going to bring that summary to here, okay? We did, all of these graphs, right? Shifting left and right, up and down, and it's, and the similarities to other functions. So what we did there, okay, we did a little summary. So let me make it just a little smaller so we can ship them, we can transport them, right? Just talk about the quadratic function per se. Okay, so we have the summary. Okay, so I'm going to bring it right here. All of these are quadratic, and we're only going to focus on quadratic. Other similar situation, okay, we're going to kind of just leave it for future studies of other functions. Okay, so we're going to remove these functions for now, and we're going to remove these functions as well. Okay, so just for quadratic. For quadratic function, right, we also study some other forms, right? We also study some other forms. For example, the multiple shifts, right? The multiple shifts. We've done a couple examples, and this is one, right? This is one. Actually, should I bring these examples over? Yeah, I can bring these examples up higher. Okay, closer to us. Because what we're doing here is that by recapping these things, these functions we studied, right? We want to present you the reason why we're going to cover the topics we cover in this section, which is completing a square. Completing a square. Okay, essentially from these three examples, right? From these three examples, obviously these are quadratic forms. These are quadratic forms, right? Well, it is a quadratic form, but in this form, right? From the first example we talk about, right? From this form, if I write it down as the general form, all I have to do is just to expand it, right? If I FOIL, right? If I FOIL this, I will get 2 times, right? X minus 2 squared, that's going to be x squared minus 4x plus 4, and then minus 1 outside. Okay, and then if I distribute the 2 to the inside the parentheses, I'll get 2x squared minus 8x plus 8 minus 1, and equals to 2x squared, right? We're going to combine like terms, minus 8x plus 7. You can see this, after we FOIL this expression, the function becomes 2x squared minus 8x plus 7, which is a special form of the quadratic function. So it is a quadratic function. But from this form, it's pretty hard to tell what is the vertex, right? What is the lowest point? What is the highest point? In this case, that would be the lowest point. But from this form, however, we can tell the vertex, right? The vertex is basically whatever x minus, right? My x minus 2, so 2 is the x coordinate of the vertex. and -1 is the y coordinate of the vertex, okay? Vertex is, so let me bring the function to in front of you, okay? So let me bring that function over. I think it's here. Okay, so after all of those shifting, right? After all of that shifting, right, which we did last time, is that the final function, which is in red, we can tell the, wait, I think this is not the right function, sorry. Yeah, I copied the wrong function right here. Okay, so this function, okay, this function, if I get rid of all the other colors, right? If I just get rid of all the other colors, just leave the red, you just save the red. Delete that one, delete that one, delete that one, and just leave the red. Okay, oops, there. If you just leave the red, you can see, right, in this form versus in this form, right? They are the same, they are equal, right? They're equal, but this form can tell us the vertex. The vertex here is this, the lowest point of this parabola. So I'm going to mark that point. Okay, so that's going to be 2, -1. It's a red dot. Okay, and in the letter form, it's pretty hard to tell what is the lowest point. What is the lowest point? But in the form we had earlier, if we had this form, however, we can tell the vertex right away. We can tell the vertex right away, right? For example, right, if I have this form, right? If we have this form, right? So what we can do, you can see if I put f of 2, right? Input is 2. By the way, this is a function, right? This function basically is a rule, right? How does this rule work? So this function will be taking an input, and that input, of course, is f. And this function value, right, will take the x, right, and the x will be subtracted by 2 and then squared. After square, we multiply by 2, and then after all of this is done, we -1, we get f of x. So that's f of 2. That's f of 2 if we put x is equal to 2. So when we put the input as 2, okay, when input is as 2, right, we substitute x by 2. And in this case, this part with the perfect square, that's going to be 0. So it's going to be 0 - 1. Okay, so when the perfect square part is 0, and that the function value is -1. Okay, and this pair 2, -1 will make the vertex. This is actually the lowest point of the curve, the lowest point of the curve, okay, as we saw in the picture. And what is the meaning of this lowest point? The meaning of this lowest point is saying when the input is 2, okay, the output is -1. The output is -1. All of the other outputs, okay, all of these other outputs will be larger than -1. So that is the smallest output possible. the smallest output possible. Okay, I know this may be a little bit difficult to understand. However, okay, look at this. Okay, since this is something squared, right? Something squared, the minimum value of a square is at least, the minimum value is 0. So we achieved 0 for this square part. Okay, and then the smallest value of this piece is 0. Okay, so the entire function achieve its minimum when input is 2. So the vertex tell us, in this case, the lowest point when the parabola opens up. So that's the lowest point. That's the lowest point. Okay, so let's look at another example. Right? So this is to show algebraically, right? If we have a perfect square form, so this is the perfect square. Okay, if we have the perfect square in this form, then we can tell the vertex. The question is, if we didn't know this form, if we didn't know the perfect square form, can we go back? Can we convert from the general form to perfect square form? The answer is yes. We're gonna, in this section, we're talking about this method called completing a square to make that happen. Okay, so you can see, knowing this perfect square, having this perfect square form is very, very useful for us, because we can then identify the lowest point. And the lowest point will tell us when the function assume minimum value. Okay, so let's look at another example. The other example is what we did last time. Okay, this one, this function. Okay, it took us multiple steps. To graph this function. Okay, it took us multiple steps to graph this function. And when we get the final function, right? So here it is. Here's our final function. Okay, so let's have an observation. Right? So we finally graph the function, right? If I clean it up a little bit, right? I'm gonna clean this, right? I'm gonna remove all of the rest. Okay, so only leave the red color. Okay, just the red. Okay. We also recognize in the process the vertex, which is the highest point in this case. It's the highest point in this case, is going to be x minus 3. The 3 is going to be 3, 5. Okay, if we do something similar to what we did in the first example, okay, so what I will be doing, I'm going to FOIL and combine like terms. Okay, so x minus 3 squared is going to be x squared minus 6x plus 9, and then plus 5. And then we have -2, multiply everything inside the parentheses. So I have -2x squared plus 12x minus 18 plus 5. Okay. Now, finally, -18 plus 5 is going to be minus 13. So this is the general form. And this is the form with a completed square. Okay, this is a completing square form. The general form doesn't tell us the vertex easily, but the complete square form tell us the, the one with the perfect square tell us the vertex very easily. So now the question is, can we reverse this process, right? If we didn't know the perfect square, can we find it algebraically? The answer is yes. Okay, so that's the task in this section, okay? Which is in order to identify the highest point or the lowest point, okay? You see, in this case, right? Let me clean this up. In this case, if I take one with the perfect square shape, right? Negative 2x minus 3 squared has a minimum value. The minimum value is 0. But negative 2x minus 3 has a maximum value. Okay, I know this is a little tricky, right? This is a little tricky. Okay, so let's show this. Okay, maximum, minimum, right? So if I pick f of 3, what do I get? I get negative 2 multiply 3 minus 3 squared plus 5. The perfect square part becomes what? Becomes 0, right? And negative that part, of course, is also 0. The final result is 5. So 3 comma 5. 3 input is 3, output is 5. Now, if I pick any, if I put any other value in this form, say if I pick f of 2, what will happen? Right, I will plug in, right? I'll plug in the place of x by 2, and this numerical value is 3. You can see 3 is smaller than 5. In other words, if you look at this picture, right? When input, okay, input, I'm going to use blue. When input is 3, the output is 5. Okay? For any other input, the output would be smaller than 5. So that's what we are saying, that 5 is the highest function, the highest output possible. You see all the other output, if the negative one, of course, they're smaller, right? For all the positive ones, right? You see these beneath x-axis, they're obviously less than or equal to 0. All these others, they're certainly, all of these are less than 5. So this is the highest point. So the output 5 is the largest value. Okay, now let's look at these two examples. In this case, after we FOIL this, right? After we FOIL this, when A, okay, compare with this form, compare with the general form, compare with the general form. Okay, if we compare with the general form, right? In this case, A is -2. A is -2. Okay, so let me remove that picture. Okay, when A is -2 in the general form, the parabola, which is the curve, okay, which is a curve. The curve over here opens downward. If we take the same function general form, okay, in this case, what is A? A is +2, which is a positive. A is positive. So, and the parabola opens down. Okay, parabola opens down. And in this case, parabola opens up, I'm sorry. In this case, when a is less than 0, parabola opens down. When a is positive, parabola opens up. I'm sorry, opens up. Okay, so now regarding parabola, right? There's a lot of information we can tell when a general form is given. But in the case we're given a perfect square form, a lot of things become easier. But what if we're not given a perfect square form, right? What if we're not given perfect square form and we want to make it a perfect square form? Okay, so that's the title of this section. Okay, but first thing first, okay, we're gonna write down our observation. Write down observation just now. You can see a cannot be 0, right? So a is either positive or negative, right? And we just saw that if a is positive, the parabola opens up. If a is negative, the parabola opens down. Is that true? Well, we have 2 examples, right? But 2 examples doesn't mean it's going to be true. Well, if true, it has to be always true, right? But here I can assure you, we're not going to be proving it. Okay, is that whenever the a is positive, the parabola does open up. Whenever a is less than 0, the parabola does open down. Okay, so this just considered it's a truth. It's a truth. Okay, if you really want to verify, then you can just make up examples the way we have shown you, right? Pick a to be positive. You're gonna graph a bunch of it. We already have some other proof, don't we? Right? We already have some other proof. For example, what are the other proof we did? Let me show you. Okay, what are the other examples we have done? Right? In this case, right? In these cases, right? And in fact, from what we did here, we actually have seen it, right? You see x squared opens up. In this case, a equals 1. Negative x squared, a equals -1 opens down. In these 3 cases, right, a equals 1, a equals 2, a equals half, all of them are positive. A's are positive, that they all open down. And the next case, x squared, a is 1, x squared plus 1, a is 1, x squared minus 1, a is 1, so all of them opened up. Okay, so hopefully you are convinced, right? And the next is, how do we do the perfect square? Okay, so how do we do completing a square, right? So our task of this section is that our goal is to convert this form. Okay, we're gonna do some algebraic, okay, conversion. Okay, so that it equals to, this is a, sorry, or did I miss that a? Yes, we must have that a. We're going to convert this form into a multiply x minus something squared plus k. This is our goal. This is our objective from a general form of quadratic. Okay, for example, right, we might be having this piece, right, which we know is perfect square form, which is right here. So it's a reversal. It's a process that reversed. Okay, and we also know another example. okay? And that is going to be converted to this perfect square. So we're going to reverse the process. We're going to reverse the process. And we're going to show you how we do that, Okay, we're going to start from simple examples. We're going to start from simple examples. So how to, okay? How to make perfect square. How to make a perfect square. Okay, and our situation, of course, typically our situation, I'm going to go by examples, okay, in quadratic case, in quadratic functions, Okay, so we're going to talk about the how to. In order to do the how to, okay, in order to do the how to, right, we're going to take the general form and we're going to study some simple cases. We're going to study some simple cases. Okay, the first example I like to talk about is that we have this general form. I have a equals to 1, b equals to 2x, and c equals to 1. Okay, how do we make this into partially there's a perfect square? And what can we do? Okay, now, because the form we try to convert to is something like that. Because the form we try to convert to is something like that, right? So one way to do it, okay, is by the following. We recognize that a is equals to 1, right? So a is equals to 1, right? So a is already equals to 1, right? So we make them equal. We can make them equal. Okay? And what we do is that we know x squared plus 2x plus 1. All we have to do is to FOIL the right-hand side. We're going to FOIL the right-hand side. If we FOIL the right-hand side, what do we get? We get x squared. Okay, you may like to just turn, pause the lecture and watch it watch it yourself. Okay, 2hx plus h squared and plus k. Okay, so if we can make these perfect square, and we know we can, right? So we will end up with these two equal. We'll end up with these two equal. These two are equal. And x squared obviously equals to x squared. There's not much to be done, right? And the x term, they have to be equal. Right? And the constant term, right? So we know that a negative 2h is 2. Negative 2h is a positive 2. And therefore, h is equals to what? Divide both sides by negative 2 equals to negative 1. So h is negative 1. We found h equals to negative 1 already, right? So how did I do that, right? I said, right? So these are constant. And this is a 2x. And this is the x term. So if they are the same, then the negative 2h should be the same as 2. So that's how we set up negative 2h is 2. And the h is negative 1. If h is negative 1, and we know that there's a constant piece, right? There's a constant piece should be equals to 1 on the other side. So this piece should equals to that piece. And this piece equals to that piece. That's what we did, right? Since we already know h is -1, we just have to find k. So h is -1. Whoops. H is -1. If I do it right, h squared plus k. No, h squared plus k. Okay. H squared plus k equals to 1. Okay, h squared plus k. This piece, okay, let me draw the picture. So this piece should equals to 2. Okay, and that piece should equals to there, equals to the same thing. They should be the same. That's what we're talking about. So h squared plus k, this is h squared plus k because h already, did I erase that? Okay, I think I did. Okay. -2h should equals to 2. Okay, so -2h should equals to 2. -2h should equals to 2. Okay, so let me put this back as h squared. So -2h equals to 2. As a result, h equals to -1. So we found h already. Okay. Once we found h, we're going to replace h by its equal, which is -1. And we know that the h squared plus k equals to 1. So that's how we get the second one. Now this is 1, this is 1, so k is 0, right? So we end up with 1 plus k equals to 1. So the consequence is that k equals to 0. We found h, we found k this way. Okay, we found h, we found k this way. So now k is 0, h is -1. So we know that in this form, we got it. And how do we put it back in? Okay, h will be -1. And k is 0. Is 0. So we're going to verify. We're going to verify, right? So we get x squared plus 2x plus 1. And what will be the latter equals to? Well, x minus -1 is x plus 1 squared. And plus 0, right? Now the question is, does x squared plus 2x equals to x plus 1 squared? You can certainly verify. When you verify, you can take the x squared plus 1, x plus 1 squared, and it just FOIL, right? It just FOIL, and it is equal. It is equal indeed. This is the one method. This is the one method. Okay, this is the one method of completing a square. I don't know if you get it. Okay, so I'm going to give you another example. Example number 2. Okay, this time I'm going to have a f of x equals to x squared minus 2x plus 3, and we want to make a perfect square. We want to make it a perfect square. And how do we do that? We're going to do it the same way. Okay, so we assume there is a perfect square form. So we assume, okay, so we assume, what do we assume? We assume that this form can be written as the perfect square form. And the perfect square form is going to be expanded. Okay. So this is going to be true. Okay, we assume to see if we can find the h, if we can find the k. Okay, i.e. that we're going to try to make these two happens. Okay, you can see x squared and x squared are already equal, and they're, so the next step, you just minus x squared on both sides, right? So this is gone, and this is gone. And then you look at the x term, right? Compare the x term. The coefficient, what is a coefficient? The number in front of x, okay? So we're gonna call this, we're gonna put a bar underneath. So these two should be equal. What it means? It means negative 2h should equals to negative 2. So negative 2h should equals to negative 2. If that is true, then h equals 1, right? You divide both sides by negative 2. So h equals to 1. We found it. And the next one, we have to identify the k. And so this piece should equals to the constant part. So h squared plus k should equals to 3. Since we already found h, right? Since we already found h is 1. H is 1, right? So we replace h by 1. So can we solve for k? Of course we can, okay? So we get 1 plus k equals to 3. And in the end, we get k equals to 2. So now we get h and we get k. We get h, we get k. Right? We just plug in. We get h, we get k. So h is 1, k is 2. If we can verify, right? We want to verify with a perfect square. If we FOIL it, right? X minus 1 squared, and we're gonna get x squared minus 2x plus 1 plus 2. And 1 plus 2, and that's 3. That's 3. So verified. Okay. So this is one of the methods of making perfect square. Okay, this is one of the methods to make perfect square. I'm going to give you one more example, and then I'm going to show you another method to make perfect square. Okay, so example number 3. And this time I'm going to give you a, something like this. F of x, okay, equals to 2 times x squared minus 5x plus 7. Rather random. Okay, I pick up this example very randomly. And I'm going to find out what will be the h, what will be the k. The a is decided, right? The a decided from the outset. So it's going to be 2 times x minus h squared plus k. Plus k. Okay? If this is the same, right? So we're going to assume, we basically assume this is the same. They are the same. We assume that. Okay, so I'm going to remove this. Just assume this. And we're going to solve for h and k. We'll solve for h and k. And how do we solve it, right? The same trick. The same trick. The same trick is that I'm going to FOIL this. Okay, I'm going to FOIL this. So what do I get? Assume they're the same, right? So this will be equals to 2 times x minus h squared. It's going to be x squared minus 2hx plus h squared plus k. Okay, and then we're going to open up the parentheses. Oops, sorry. We're going to open up the parentheses. equals to 2 times x squared minus 2 times -2, that's -4 hx plus 2h squared plus k. Okay, and because these two are assumed equal, okay, so we assume these two are equal, the assumed equal, right? And of course, 2x squared equals 2x squared. So we can subtract 2x squared. So these are going to just be removed, right? Because they're the same on both sides. So all we have to do is treating this piece equals to that piece because they are both coefficient of x, right? They're the numbers before x. So -4h is going to equals to -5. So these two are going to be equal. And 7 is going to be equals to this piece. Okay, so these two pieces and +7 are going to be the same. Does that make sense? Okay, so then, right, so -4h is equals to -5. As a result, h is equals to 5/4. 5/4. Divide both sides by -4, right? So h is found. And next, right, 7 is equals to 2h squared, right? So 2h squared plus k is going to equals to 7. We know h already, right? We know h already. So we just have to do some operation, okay? Or we can just go ahead to write down the k. Okay, so k is equals to 7 minus 2h squared. And because we already know h, right? So now we're gonna plug in the h, right? So 7 minus 2 times h, right? This is our h, 5/4 squared. So in the end, right, we just have to operate on this fraction. Okay, on this fraction, which is 2 times, right? 2 times 5 squared is 25, and 4 squared is 16, right? I know you guys love fraction. That's great, right? So 2 times 25, so the top is going to become 50. Now we're going to find common denominator, right? 7, we're going to make a common denominator. That's going to be 16/16, right? 16/16. Yes. This method I'm talking about, right, actually has quite it can find you h and k always. Okay, so it has an advantage. Does it have its disadvantage? The disadvantage, you may deal with more complicated questions. Okay, but anyway, without further ado, 7 times 16, 7 times 16 minus 50. So if we simplify, okay, let me make the fonts just a little bit larger so you can see the fonts. You can see the subtraction sign. 7 times 16 minus 50, so we can calculate that number on the side. Get 62. So in the end, right, we get 62/16. Okay, simplify, right, 31/8. 31/8. So we found h, we found the k. So h is found, right? K is found. So k is 31/8. Okay, h is 5/4. 5/4. And where do we take them back to? Right here. We're going to take them back to here. Okay, h 5/4. Just plug in. K is 31/8. 31/8. Okay, you know, this method is actually rarely taught in any textbook. Okay, in any textbook. At least I haven't seen it. At least I haven't seen it. Okay, a similar method actually is used in calculus 2 for other purposes, not necessarily for quadratic. It's just a different application. Okay, so I introduced this method to you guys probably for the first time. Okay, so but I'm going to teach you another method of completing a square. Okay, I'm going to teach you another method of completing a square. So this method, since I taught it first, right? And I actually think it's a very effective method. It can find h and k for you all the time, okay, without too much hustle. So if you get it, great. If you don't get it, no problem. We have another method to teach you. The other method is actually more commonplace in completing a square. This you would say this category of question. Okay, so completing a square. We still go by examples. Right? Suppose I have a quadratic function, right? X squared, and this is going to be minus 2x plus 3. You saw this example, right? We saw this example earlier. Right, you saw this example. We already know the answer actually, okay? But I'm going to use this example to introduce you another method of completing a square, okay? So what this does is that we're going to use the mathematical principle number 1, okay? So what do we do here is that we're going to do x squared minus 2x plus 1 and minus 1 and then plus 3. So what I did here is I add a 0. I basically add a 0. We know that anything add 0 stay the same, right? Anything add 0 stay the same. I think this is principle number 2. But anyway, we add a 0, but this 0 is 1 minus 1. Okay, 1 minus 1. So we add a 0. So this expression is still the same as the latter expression. And now what we have here is that we put these 3 terms together. We put them together and negative 1 plus 3, and that's going to make 2. So if you can certainly go back, you can go backward, very fine. You can go backward. Okay, you just, all this we're doing by adding 0 is to ensure, okay, it has 2 purposes. We add a 0 and we choose our 0 carefully. So the choice of 0 fulfill 2 purposes. Number 1, right? The first purpose is to justify, to make sure equal sign is validated. Okay, the second reason is make a perfect square. Make a perfect square. Okay, i.e., this is going to make a perfect square. How do I know? If we factor, if we factor x squared minus 2x plus 1, if we factor this, what do you get? Some of you might need some help with factoring. Some of you may not. So I'm going to show you some simple steps to do the factoring. Okay. There are other ways of factoring. So here I'm going to just do, I have x squared, right? I'm going to do minus x plus 1, right? So I just split minus 2x into minus x, right? And then I will regroup. I bring these two together, right? So factor x out, we get x minus 1. And these two, I'm going to factor out the negative sign. So I have negative. I'm going to factor out the negative sign. Okay, so between these two, I factored out the negative sign. So that becomes x minus 1. And with x minus 1, we have x minus 1, right? This is the common factor now, right? So we have one term here, right? The x minus 1 is a common factor, and we get another factor. So that's obviously is x minus 1 squared. Factoring technique, there's so many factoring techniques. So here I will just keep it short. And this way you guys also understand this factoring technique, right? So what do we get here? We actually got the perfect square. Then your question might be, how do you know you're going to add 1? Well, because I know x minus 1 squared is going to be x squared minus 2x plus 1, I already have x squared minus 2x. All I needed is just plus 1. So that's why I add a 1. If I add a 1 without subtracting 1, the equal sign will be off balance, right? So we have to subtract 1. So the first adding 1 is to make the perfect square. The second subtract 1 is to validate the equal sign. Does that make sense? Okay, so this process, okay, we have done the completing square already, right? You see we get the same results. We got the same results as we get the same results for example 2, which is x minus 1 squared plus 1, right? That's the same results. Using this method, right? What we need to do is add a 0 and carefully chosen the number you add and subtract. And you add the number to make that perfect square and subtract the same number is to validate the equal sign. So this requires some levels of familiarity with the following perfect squares. For example, this piece, x minus 1 squared, right? It requires a certain level of familiarity, right? And you also be x plus 1 squared, right? And you also like to have familiarity for these. But when you compare these two, right, and you compare more of them, right? Say I have x minus 2 squared. And here we're talking about academic questions, really. Academic questions, it can be, it can be pretty limiting actually. Okay, so if you're familiar with certain perfect squares, right, and their general form, right? So you're familiar with these general form, in particular, these general forms, a plus 1 squared, right? We FOIL that. Or a minus b squared, right? If you can be familiar with these forms, you're set to do these methods, okay? So these methods will also, this method is taught more often. And of course, there are formula method, okay? which I'm not going to talk about it. Okay, if you are familiar with formula method, it's very similar to the first one we talk about. Okay, but it's slightly, you have to memorize certain formula. Okay, so let's take some other examples. Okay, example number 5. Okay, so this time I'm going to give you an example of to make perfect square. Okay, f of x equals to x squared. Okay, minus well, maybe plus 4x minus 5. Right? When you see this, you'll be thinking, that looks familiar, right? That looks familiar. Look, we have x squared plus 4x. Right? The question is, how do you get to select these numbers, right? How do you select these numbers? Is there a pattern? Is there a pattern? And the answer is yes, there is a pattern. There is a pattern. Is there a pattern? You can find patterns from these examples. Okay, I would encourage you to do more of these. I would encourage you to do more of these. For example, you can do x minus 3 squared, but these are still actually rather limiting because these are cases for a equals to 1. So what if a is not equals to 1, right? What if a is not equal to 1, right? So I really think the first method I taught in this lesson is a more, I would say, is a more universal. Okay, it will always get you what you need for H and K. But the method I'm teaching right now, the second method is more commonly taught, maybe for academic reasons, for whatever reason. Okay, so I'm going to have to teach this method. So is there a pattern? And the answer is yes, there is a pattern. Okay, so what I'm going to do is that, you see, in this case, you recognize it right away, right? How about, okay, so after this example, right? So now we're gonna work it out. We're gonna work out this case, right? You can see depends on the familiarity. Okay, depends on your familiarity. So, well, familiarity counts for a lot, right? So you're gonna choose you have minus 5, right? We have minus 5. Since this is something we're familiar with, right? Familiarity. If you're not familiar, get familiar, right? After all, you just I already show you how to do it, right? Just practice. Take a piece of paper, pencil, foil, and soon enough, you're going to be familiar with them, right? You're going to be familiar with them. All right. Since we make a connection here, right? And we know that if we just add 4, we're going to make that perfect square. So we need to plus a 4. If we plus the 4, the equal sign isn't off the balance. So we have to subtract a 4. So now we're just adding a 0. So the equal sign is justified. Does that make sense? So the first number you add, okay? The first number you add to make the perfect square. The second number you subtract the same number to keep the balance of the equal sign. So you can still use equal sign. Otherwise, you're going to make a mistake. The equal sign will no longer be valid. Okay, so this is the same as we got the perfect square now. So that's going to be just what? It's just going to be x plus 2 squared minus 9. So perfect square is done. Perfect square is done. So it relies on familiarity, right? Familiarity-wise, I'd like you guys to work on familiarity, and eventually I would like to show you how to look at these. Okay, but right now these seem to be rather abstract. So what I like to do is I'm going to take all of these forms, and make a table to see if you guys can find some patterns for us. Okay, so I'm going to make the table in such a way. Okay, we need more rows, but just 2 columns. Okay, so I'm going to put these, right? I'm going to combine these two because they are almost the same, aren't they? Right? So I'm going to make it like plus minus, right? Plus minus. Does that make sense? Plus minus. For x plus 2, and this will be also plus minus, right? Plus is for plus, minus for minus. There's one corresponding. This is a kind of compact form. So x plus 3 squared, right? So I'm going to do plus minus. So what pattern have you found? Have you seen this pattern? For example, in order for you to see the pattern, I'm going to remove this number. I'm going to remove this number. Can you tell me what the next number should be to make it equal? And soon enough, you'll find, okay, you can pause the video. You can pause the recording right now to find your pattern. So assuming you're back now, okay, you're back now. So this number I should add is actually 2. Okay, this number in front of x divided by 2. And this pattern, the same. This number 4 divided by 2 squared. And this number we're going to add is going to be 6 divided by 2 squared. So now if I'm doing x plus minus 4, what do you think we should be getting? Right, you're certainly going to have x squared plus minus, right, 8x, and this number we're adding should be what? Should be the 8. Do you guys see that? Should be 8 divided by 2 and then squared. So this is the pattern. I'm sorry, this is plus. This is the pattern where we have found. Now a little bit fast forward, a little bit fast forward. If I have x squared, okay, minus 10x, I want to make it into a perfect square. What should I be adding? What should I be doing? What should I add to make that perfect square? X minus what? What should I be adding to make that perfect square? You're right. Okay, I think I almost hear you. I will take the 10 divided by 2 and square it. And this number, which is a 5, should go here. And that will make a perfect square. You can totally verify it. Okay, so familiarity is one thing. So after we see familiarity, we also should see what? What if I forget, right? Well, we try to find patterns. We try to find patterns. Okay, now one more example. Okay, one more example. And here you actually see x plus minus 5, that example, right? So x plus minus 5 squared equals to x squared plus minus 10x plus, right? Always plus, we take the 10 divided by 2 squared. So that's the pattern. That's the pattern. But these patterns, you can see it works for what? Works for if there's no other numbers in front of x. What if there's a number in front of x, right? So that will be, and this technique will show us something else. So next, I want to make sure you get this, okay? For example, I have x squared plus 3x. What number should I add that such that it gave me a perfect square? I know it's going to be x plus something, but what should this number be? What should be the heart? And what will be the question mark? You can pause the record. You can pause the recording and come back. And now I assume you're coming back. Okay, so what should be the question mark? The question mark should be, I take the 3 divided by 2, and that's going to be squared. So my heart is this number. And that works every single time. Okay, that works every single time. Okay, so if we have 1x squared, right? 1x squared. Then you say, how about 2x squared, 3x squared? We'll get to it. We'll get to it. Okay. Now it comes to here. These general formula actually gave us the ultimate guideline. So even you don't have familiarity, even if you don't have that familiarity, you can still work it. Right? For example, if you have a squared plus 2ab, right? What should you be adding that will give you that perfect square? Of course, you know the answer, right? What number should be here? You already know the a, right? This is a and this is 2a. So this number, okay, this number is going to be, what should this number be? It should be 2b divided by 2 squared. Okay, so you're gonna 2b divided by b is b squared. This may look a little bit like a tongue twister, right? But because in most of cases, like in case like that, right? In this case, right? When we don't know this, right? When we don't know these two quantities, right? You can see a is x, a squared is x squared, right? A is x, 2b is 3. 2b is 3. So this piece is going to be 2b is 3, right? So 3 divided by 2 and then squared. I hope this helped you to understand. Okay, I hope this helped you understand. If this is not enough, just let me know, right? Just let me know. This is the commonly taught method of completing a square. Okay, and then we still haven't answered the question, what is the 2x squared plus, some other stuff? We'll get to it. We'll get to it. Okay, right now let's practice. So I'm going to give you some examples. Okay, pause the recording as needed. Okay, and this example I'm going to call example number 6. Okay, still completing a square. So we have a f of x, and we're going to have x squared, okay, plus x minus 1, right? Obviously, these are not in your familiar formula, right? In your familiar formula, you have these nicely, neatly, right? So then you say, well, I cannot get familiar with everything, right? So ultimately, you will have to deal with that, right? So if I put these two together as the combined form, that should be our guideline. So these two formula really is the ultimate tool you can use. Okay, so if you're super familiar with those stuff, great. But the good news is that these examples actually covers a lot of academic questions. Okay, so if you know them, great. If you may know like x plus minus 6, plus minus 7, plus minus 8, plus minus 9, those familiarities counts for a lot. You probably, covered a good percentage of academic questions, right? But there's always some exceptions. There are always exceptions. So in this exceptional case, right, like in this case, it's not in none of the cases we've seen before. So we basically are in a situation, and of course here we know that it's going to be plus. We're going to be a plus. So we're going to play with this formula, right? We have x squared. Our x squared is a squared, right? So x is a. So this is a. X is a. We don't know b. We don't know b, right? So x is a. So this is x. So 2 times b. So I'm going to just bring this. So 2 times b. We know 2 times b, don't we? Do we know 2 times b? Because a is all substituted by x. 2 times b, we have x squared plus 2bx. So here we have x. So 2b is 1. Do you see that? 2b is 1 in comparison. Okay, so 2b is 1. Okay, 2b is 1, and b is 2b divided by 2. Okay, so what do we do now? So 2b is 1, right? So what should we be adding here? Okay, to make that perfect square. Okay, we still have that minus 1. We just need to add a 0, and this 0 is going to be made in such a way. We're going to add, you see, the number before x is 2b. That number is 1, right? So we're going to take that 2b, which is 1, divided by 2, parentheses squared, and subtract the same number. And this, it will make that perfect square. So that pattern we observed from the familiarity, right? Which we take the number before x divided by 2 and then square it. We found the b and the b squared. Okay, that pattern still works. The ultimate source is these two formula. Okay, as here we use exactly that pattern, even though this is not in the familiar form. No problem, no fear, right? You just look at these two. The term before x is 1. So you take that 1 divided by 2 and you square it. So you found your b, you found the b here, and you subtract that b squared, you add this perfect square to make that perfect square, and you subtract it. You subtract the same number you added to maintain the equal sign. I hope this is super clear now. Okay, so ultimately, what is my perfect square? Well, that is going to be, since we already found the b, right? The b here is half. So b is half. This is half. Half. We found it, right? So that perfect square is going to be x plus half squared. Okay, So this part make the perfect square. Then you say, how about these? Yes, you have to operate it. We have to operate it. So minus half square, that's minus a quarter, minus 1, right? And we have to find common denominator between these two. And then we just need to be patient with us, with ourselves, right? And negative 1, well, 1 is 4/4, right? And we're almost there. We're almost there. So this is going to be minus quarter minus 4/4, combine the like terms. So that's going to be minus 5/4. There you go. We know the goodness of getting these perfect squares in our quadratic form, which is to, we will have identified the vertex. We will have identified the vertex. Okay. We're going to do the vertex thing later. So here we really just focus on completing a square. And let's continue. Okay. Example number 7. Right. So now we know about completing the square. Feel free, you must practice and doing homework. I have some homework question for you guys to do completing square. Using either method, I actually want you to learn how to use both methods. The next question now, we're going to tweak it, right? Because our goal is to be able to make perfect square for all of these forms, whether A is 1 or not, right? We know how to find for A equals to 1, right? So what if A is not equals 1? For example, A is negative. What do we do? Right? What if this happens? What if this happens? What if this happens? Right? Can we make that perfect square? What do we do? What do we do? No fear. I'm here to help. Okay. So what you like to do is that you're going to leave the 3 just tagging along, but you focus on these 2 terms. Okay. Between these 2 terms, you're going to factor out the negative number or whatever A is. Okay. So I'm going to factor out the negative sign and I'm going to put x squared. And this time it becomes minus 2x because I factored out the negative sign plus 3 just tagging along. Okay. Once we do that, once we have done that, we're going to make the perfect square inside the parentheses. Okay. We're going to make the perfect square inside the parentheses. You already know what to do, right? So it's just plus 1 minus 1, right? Plus 1 minus 1. This will be very much relying on the familiarity over here, right? Okay. You can either use the familiarity. You can use the familiarity. If you're not familiar, you just take the 2, right? You can just take the 2. Take the 2 here, divided by 2 and square it, right? And you do the same thing for the number you're subtracting, same thing, okay? Now, we're close to it, okay? So this is a 1 after all. This is a 1 after all, right? And this is just a 1, really, just to keep it simple, right? Just keep it simple. Now, we need to be very careful operational wise. So what I'm going to do is actually I'm going to make a bracket here just in case we make any mistakes, right? And these 3 terms, I'm going to put them in parentheses. Oh, wait, sorry. These 3 terms are going to be in the parentheses because they make the perfect square. But negative 1 is here. There's a negative sign outside the bracket. So we have some layers of stuff to deal with, okay? So this piece make that perfect square. So we got x minus 1 squared, right? And then we have to take this negative 1 outside, right? So when we take this outside, we need to be very careful. We need to be very careful. Okay, we're going to put the negative sign, multiply the square part, right? I'm going to take the negative sign, multiply the negative one part. Okay, so negative sign times x minus 1 squared, that's just negative x minus 1 squared. We're not going to FOIL this. And negative 1 times negative 1 is going to be a positive one. Okay, and in the end, we got a plus 4. Okay, and now if you compare this form, right, with the perfect square form we just completed, right, you can see the A is still outside, minus H plus K. So it's really still this form, x minus H squared plus K. So once we get these completed forms, completed squares, the vertex can be easily identified. So this is the one you have a negative sign in front of it, right? A is no longer 1, A is negative. That's what we do. And you say, what if A is 2, 3, 1/2? No problem, we can handle them. The major technique is just to pull it out. Okay, so let's look at this example. F of x equals to 2 times x squared. Okay, I'm going to say plus 6x minus 3. Okay, what do we do? Well, let's go. The techniques is very similar, okay, to the previous example. So what we do is that we focus on these two terms. I'm going to factor out the 2. So we get x squared plus 3x, and there's a minus 3 outside. We just maintain the equal sign. And once again, right, we're going to make a perfect square, don't we? Right? So I'm going to plus something and minus something. So how do I choose that something to add to? Well, we're going to take the 3 divided by 2 and square it. I'm going to subtract the same number. So once again, the first number is to do what? Okay, so I'm going to introduce the bracket just to make sure we don't get confused, right? We add a number and subtract the same numbers. We add 0. The first number is to make the perfect square with the 2 terms in front of it. And the next term, subtracting it, is to maintain that equal sign. So that equal sign is validated. Okay, and then we're going to group. Okay, these 3 are going to be grouped into the perfect square. Okay, so that perfect square is found. Plus. Okay, you may like to verify on the side. And of course, you may just square this piece. That's going to be 9 over 4. 9 over 4. Okay. So these 3 make the perfect square. If you're not certain, so did I get it right? Well, just take this piece, FOIL, right? You just FOIL, right? You should get x squared plus 3x plus 9 over 4. Or, okay, this is not the only way. Or you factor. In this case, factoring seemed to be rather, doesn't seem to be easier. You can factor that. You should still get the same thing. You still get x plus 3/2 squared. Okay, so I leave that for you. Just pause the recording and try yourself. okay? So now we get the perfect square part. And we're gonna move this part outside the bracket. So I'm gonna take the 2, multiply the perfect square part, right, times 2. I'm gonna also take the 2, multiply 9/4. And then subtract the 3. Never forget this minus 3, okay? It's just tagging along, even though it doesn't do anything, but doesn't do anything until now. This piece is already finished. This piece is already finished. Subtracting, right? 2 times 9/4, 2 and 4 reduce, so we get 9/2 minus 3. Right now, we want to make common denominator, so that's going to be 6/2. 6/2. Okay, common denominator, this is still -3, right? There's the same thing. Combine the constant, right? So this part stays. And that part minus 9/2 minus 6/2, that's going to be minus 15/2. Finished. Okay. Be very patient with yourself when you read this. Okay, when you read this, I'm going to give you a couple more examples. Okay, I'm going to give you a couple more examples. Okay. Let me give you another example. This is bound to be a long lesson. Okay, let's see how much time has passed. Well, we just have to do more examples. Okay, you guys just have to, you know, you just have to, I would say, you just have to maybe watch it in, you know, in a few pieces. Okay, and that the bottom line is I wish you guys could come back to watch this if necessary. And I'm almost certain you need to come back. Okay, I talk about a lot of techniques, examples here. So as you're doing your examples, right, you will, well, I hope it's not such a long journey, but we have to practice. Okay, I don't want to make another video, so it's going to be fragmented. Okay, so now let's do another one. This one, okay, I'm going to do another one with negative coefficients in front of x squared. So this one is for you to practice, right? Negative x squared minus 4x plus 1. Okay, try this one to make perfect square. Okay, example number 10. Example number 10. I will make a similar example. Hopefully, actually, I'm going to make it just a little bit simpler for you. Okay, so 2x, I'm going to plus 8x here. Plus 2. You can see I'm really just making examples, you know, on the fly. You may like to pause this. You may like to pause this to try it. Okay. And for the first one, write it down and go back to watch the example and do it step by step. And the second one, right, you copy the question, you go back to see how it was done. So at this point, you may like to pause and go back to watch. Okay, go back to watch. You can take your time, but I'm just going to, I'm just going to assume you're coming back. Okay, you're back. Okay, practice. You must commit yourself to paper, pencil, going through the process. Okay, I promise you most of academic questions, are in comparable difficulties, okay? And most of them are actually on the easy side, okay? So do not despair. So the same thing, okay? The same idea. I'm going to focus on these two, still do the +1. So between these two, I'm going to factor out the negative sign. So I have x squared plus 4x plus 1, right? And now once you've done that, everything becomes much easier. So you just do 4, you take the 4 divided by 2, 4 divided by 2 is 2, so it's going to be 2 squared. You add a 2 squared and you subtract a 2 squared. Can you write 4? Of course, you can write 4, no problem. Because they're the same number, right? If they're the same number, nobody can take points off you, right? So these 3 will make the perfect square. But at this point, I'm going to make the bracket because I always want to make sure it's absolutely clear. And these 3 terms make the perfect square, right? So making these distinctions, making it clear for you, it's easier for you, it's easier for your readers. So the first part is just going to be x plus 2 squared. And of course, this is -4, right? And then you're going to distribute, right? You're going to distribute the negative sign inside the parentheses, right? So this piece, get a distribution of the negative sign. And -4 multiply -1, that's going to be +4. And then you +1, right? So finally, you get the completed square done. And that's 5. Okay. Let's do this one. Let's do this one. Okay, I assume you have probably paused and come back, right? You pause and come back. I promise you this is going to be the last example, okay? So, okay, 2 times the same technique, x squared plus 4x minus 2. Oh, I did make it easier for you, right? So you're going to plus a 4 minus 4. Oh, this is super easy. I think you should be able to do these now, right? And then it's just going to be 2 times the bracket, and then these 3 makes the perfect square. X plus 2 squared minus 4 minus 2 outside. And we're almost done, almost done. 2 times x plus 2 squared minus 8 minus 2. So in the end, it's going to be minus 10. Okay, so that's completing a square, Okay, so once the completed square is done, okay, we talk about 2 different methods. The third method using formula, I'm not going to talk about it, okay, because I'm not for memorization. Okay, if you happen to remember those formula, wonderful, but just make sure you don't confuse yourself. Just make sure you don't confuse yourself. Okay. So until next time, thank you for watching.